Hi, I'm Akshat Kaushik, a final year software engineering student with a budding passion for open source development. I will be taking you guys through my Capstone project, WebSVF, that I've been working on since last December with my team of fellow developers under the expert supervision of Dr. Yule. At the beginning of the project, we had a simple objective to create a graphical user interface for the open source static bug analysis tool called Static Value Flow Analysis or SVF. As we made progress developing the application, it transformed into something much more. Our team saw great potential in our tool as it started to come together, and we started brainstorming ways how we can take this code analysis and apply it to a much larger scale. Which brings me to the problem that the project attempts to address: software vulnerabilities. Nearly 90% of the code being written and used today is based on open source code. While I love open source code, the number of software vulnerabilities being discovered in it are cumulatively compounding at a staggering rate every year. And it comes down to the companies using this software to fix the bugs for the users. That brings me to the second issue developers face. These vulnerabilities are not caught at the time of software development because the analysis tools being used at the time of development aren't configured to catch these undiscovered vulnerabilities. That's where WebSVF comes in. The backend tool powering WebSVF iteratively analyzes the data and flow of information for increased precision in detecting errors in both areas. Users can write their own tests to add to the SVF analysis suite to configure them for new discovered vulnerabilities. At the current stage in development, WebSVF provides an interface for users to interact with the bug analysis reports generated by SVF in two main ways. First, through a bug report, which takes the command line bug analysis information given by SVF and transforms it into a modern website-like bug report. Second, through a 3D force graph, which allows users to visualize the entire project as a code map, highlighting the files by color coding them based on the errors that exist within them. A user can also find out the flow of information across any single file by clicking on it. We chose not to create a dedicated interface for these features as it would involve yet another round of UX design and testing for no particular need for the user for another integrated development environment in an industry already full of such software. We instead chose to publish WebSVF as plugins to the most popular development environment, Visual Studio Code, which is a free-to-use open source software developed by Microsoft that is available readily across all platforms. It also has a robust extension API which allows us as developers to migrate our code as extensions to the environment with minimal effort. The WebSVF interface can be installed as an extension on any installation of VS Code, whether it is installed as a desktop application on your system or if you're using it through a web browser installed on a server somewhere. This is a quick demo of the bug report section of WebSVF. You launch the bug report by clicking on the button in the bottom left section of the status bar. Once it's done setting up all the necessary files, it's going to open up the bug report inside the VS Code browser by splitting the view in half. Once it's launched, it's going to give you an overview of all the bugs that were found in the report and list all the types of bugs in form of a table. You can unclick them, and in the lower half section of the bug report, it's going to give you an analysis of all the files and the bugs found in them. You can click on the file itself to take you inside that file. Then you can click on each of those errors to give you reference lines for all the lines that were affected by that error inside that file. And you can click on the bug report icon again to close. When I started working with the project last year, the WebSVF research was focused on working with a pre-configured version of SVF. At the same time, we were targeting a VS Code environment that was hosted on a server. Unfamiliar with both of these environments, it was very difficult for me to get started with them. At the same time, the code server we were using to host our VS Code instances online was in very early stages of development. While I was fortunate enough to conduct many meaningful face-to-face meetings with my supervisor and development team before the global pandemic, majority of the project was developed using online consultations, which can be especially challenging when you're working with team members across different time zones. Until recently, I was skeptical about our project's outcome due to all the factors adversely affecting our development. But as they say, slow and steady wins the race. And we did just that. We were not only able to successfully integrate our project to work in a local environment, but also deploy it to work in an online VS Code workspace, which we were having tons of problem resolving when we first began. This allowed us to look into the next stage of product innovation and transform our tool from a standalone bug analysis tool into a platform, allowing users to create code spaces from our website. These code spaces can be configured to have our analysis plugins as well as any software required for development pre-installed before they even launch this space for the first time. This eliminates any issue where developers aren't able to set up the correct software in their environments and begin development. This project began with innovating a better way to show the user the analyses performed by the SVF tool, which led to the creation of WebSVF, a standalone analysis tool for developers to analyze their project and be able to see and interact with the results. In the next stage of the WebSVF project, our team aims to provide developers the ability to create multiple instances or code spaces pre-configured with the tools and services required for development. We plan to create a free tier where every user is allowed to create up to one code space with restricted hardware resources on our platform. They may then choose to share this code space with others for collaboration. Every one of these code spaces will take up resources on a server hosted by us developers. We're thinking of creating a paid subscription plan for teams and enterprises will allow much greater flexibility, enabling users to create multiple instances of the same code space pre-configured with the right tools and software required for development, update the configurations for these code spaces in real time, as well as assign a code space to different team members for them to work on. As we were thinking of ways to broaden the reach and adoption of our WebSVF analysis tool, we thought about offering WebSVF as a platform which would allow users to create their own development environment from anywhere, accessible on any device, and still be able to run WebSVF's analysis tools to test and secure their applications. Our team believes in the potential of the service, and it won't be long before we start using it for development ourselves to demonstrate the ease of use and benefits of the platform. We are now looking for seed funding for our project to be able to continue developing this platform as well as cover the incurred hosting and production costs during this process. To bootstrap our search for investment, we have already signed up our research project WebSVF as UTS startups as well as registered for the On Accelerate as well as the UTS Tech Accelerator programs as we continue to build our commercial model and prepare to launch the platform.